Okay, so here we have the SRK equation of state and the fact that the compressibility factor is Z equals PV over RT. And with these two facts, I'm going to show you how to come up with a cubic polynomial in terms of the compressibility factor. And where's my marker? And I'm going to start by first making this equal to Z. So got to multiply everything here by b over rt to make each side equal to z. So we have z is equal to rt over rtv over rtv minus b minus a over rt, no, av over rt, and v plus epsilon b times v plus sigma b. Now, my sigmas are going to look like 6's here, so excuse that. And then we notice these cancel out. And then you see how there's all these v's everywhere? Well, we can divide everything by v, or just at least factor it out. So that way it becomes z is equal to 1 over 1 minus b over v. Or actually, we're going to divide everything by v. Minus a over rt over 1 plus epsilon b over v, b being the excluded volume and b being the specific volume, times v plus sigma b, or v plus sigma b. And with this, what we can do is we can take out another v here, so it'll be, this will turn into a over v rt over 1 plus epsilon b over b times 1 times 1 plus sigma b over v. From there, we can use the fact that the specific volume is equal to zrt over p. And then we can change all these v's into something a little more reasonable. Well, not necessarily more reasonable, but we can change it into dp over zrt. So we want, because we want this all in terms of z, and we don't want volume in here. So evp zrt. Oh wait, well, let's just change this to 1 plus sigma b p over zrt. Anyway, over there. And here's what I have so far, so you can see it. And so from there, we have this thing from a textbook. Let me check my notes to make sure it's correct. Beta is equal to bp over rt. So then, with that information, we can change all this to betas. So it'll be z is equal to 1 over 1 minus beta over z minus a over rt. Okay, I just realized I did not put the v, change the v over here, so this will actually become a, it's not a capital A over r squared t squared z, ap over r squared t squared z. So that way that'll be minus a p over r squared z, no, r squared t squared z over 1 plus epsilon beta over z times 1 plus sigma beta over z. And another thing that we learned from the textbook, let me make sure it's right, is Q is equal to A over BRT. And from there, we're going to want to split this top part here, A over, no, A times P over RT times 1 over RTZ. And that way we can have this right here is equal to and this right here is equal to beta over B. And so then we're just left with A beta over B RTZ. And there we can use this and make it QBZ. No, QB over Z. So this whole thing right here changes to Q beta over Z. I don't know why I said B. And so what you'll notice is that we've got Z's all throughout here, right? And we don't want Z on the bottom when we are doing any sort of making a polynomial. So we're going to divide everything by Z. So this has already got a Z here, and that'll cancel out. That will multiply in here and make it something, well, I'll write this out. So Z is equal to 1 over Z minus beta minus QB over Z plus epsilon beta times Z plus sigma beta. And actually this is not equal to Z. This is equal to 1 because I divided by Z. My bad. And then from here, what you want to do is get a common denominator here. So cross multiply everything, and it'll come out to be something along the lines of 1 is equal to Z plus epsilon beta times Z plus sigma beta minus Q beta times Z minus beta over Z plus epsilon beta, blah, 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 epsilon beta, sigma beta, minus, no, not minus, just times Z minus beta. Okay, so now here's what I've got so far. And what we're going to do right here is multiply all of this together, FOIL it out, and you'll get the nice big long mess of 1 is equal to Z squared plus epsilon plus sigma. I'm going to erase this here just so I have some room to write. Epsilon beta times Z plus sigma, or no, epsilon sigma beta squared minus Q beta Z plus Q beta squared over, same thing here, so I'm just going to write ditto, no, over, I believe once this multiplies out, you multiply Z minus B times this polynomial, so it's Z, it's a nice long one, Z cubed plus epsilon plus sigma beta Z squared plus epsilon sigma beta squared Z minus Z squared beta minus epsilon plus sigma beta squared minus epsilon sigma beta cubed. And in order to make this a polynomial, we've got to multiply everything over on the bottom to the other side of the equation and factor it all into the same side. And to spare you the time, I did this on my own. It comes out to be, let's see, what did I write down? A nice big long 0 is equal to z cubed plus z squared times epsilon plus sigma beta minus beta minus 1 plus z times epsilon sigma beta squared plus q beta plus, or no, minus epsilon plus sigma beta minus epsilon plus sigma beta squared, and that's the bracket, minus q beta squared minus epsilon sigma beta squared minus epsilon sigma beta cubed. And there we have derived the compressibility factor polynomial of the equation of state.